G'day, welcome back. Mr. Bennett here. Obviously going on from our Cyclotron video from the previous one. Alright, so what we did in our last one, we talked about the idea of the Cyclotron using an alternating potential difference between the two Ds, and then we talked about the path of the cyclotrons, but we know the magnetic field and the centripetal force must be equal. So therefore we've derived this equation here, where we know that the radius of rotation is dependent on those things there. Alright, so that's really useful. Now the other thing we know about the cyclotron is that it is going in really a circular path, and we know that in a circle that the velocity that we actually have is equal to the 2 pi r, which is the distance that's travelled all over the period. Alright, so if I rearrange this equation over here, I can get V is equal to simply BQR all over M. That has to be the same velocity as what we've got over here, so what I can do is equate those two things. So I can have BQR all over M is equal to 2 pi r all over t. Okay, so we've got an r on both sides, we can get rid of that. We can rearrange this and we can say that t goes to the top line is equal to 2 pi m all over bq. Okay, now interesting that the period of rotation is independent of the radius. So you don't need to know the radius to know the period. Now, why is that important? Well, if you want to set up this alternating potential difference between the two Ds, so you can accelerate the charged particle and it can pick up more kinetic energy, all you need to know is the mass of the particle, the magnetic field strength and the charge of it. And it doesn't really matter how far the radius is, it's still going to be able to work the period out. Right? So that's really useful in terms of being able to set up that particular cyclotron to actually work properly. So that is a really useful formula, is working out the period of rotation, so you'd need to know that. The other thing that we might want to know is the kinetic energy of the particle as it actually leaves the cyclotron as well. So kinetic energy, rather than using Ke, we'll just use K, and we can just know that's equal to a half the mass times by the velocity squared. Now, if I rearrange that equation there, which we have, I can say the kinetic energy is equal to a half of the mass times by BQR all over M squared. So what's going to happen here, I'm going to get simply 1 over half, that's going to be mass, B squared, Q squared, R squared, all over mass squared. So that allows me to write the final equation, I think, which would be, that's equal to B squared, Q squared, R squared, all over, now that's going to cancel with that, all over 2m, and that's a formula that I have for my kinetic energy. So that's a really useful formula. Now you could be asked to derive this one, that's probably something they might do, or they could ask you to derive or show that the period of rotation is independent of the actual radius. Alright, so you need to be able to be familiar with all of these different forms of the formula. And again, it's probably one of those things where if you think about it, you're starting from a very, very simple base. You're starting from this formula here, and you're starting from this formula here. And everything else is derived from those two formulas. So if you can get to that formula there, and that formula there, you can derive anything from pretty well those two forms. So you need to play around with that, get familiar with it. One of those things where sometimes in life you just have to actually learn it. You need to be able to do it. And the only way you're going to practice this and get good at doing this is actually by sitting down with a piece of paper and trying to do it from scratch and learn it and make sure you understand it. All right, so they are basically the key formulas that you use for a cyclotron. So when we look at the sort of questions that you'll get asked in your tute book and in questions, they will ask you to work out what the radius of rotation is. They will ask you to work out what the period of the cyclotron might be, and they might ask you the kinetic energy of the particle. How much is it going to pick up? All right, so they are all things that you will need to be able to do. So we'll do some of these questions in class. So that's the key derivations that you do need to know though.